Thank you to EXPLORIST.Life for sponsoring today's video. Welcome to my channel. My name is Lauren and I am self-converting my Ram ProMaster to live, travel, and work in full-time on the road. In today's video, I show you how I installed my entire electrical system from start to finish with the EXPLORIST.Life All-In-One Wiring Kit. This video will include planing tips, prepping the box to house all my electrical components, highlighting tools you'll need for the install, wiring the Battleborn battery bank, the Victron Lynx distributor, the chassis ground, the Victron MultiPlus Inverter-Charger, the 120 volt AC distribution panel, shore power, the 12 volt DC fuse panel, the Victron Smart Solar MPPT charge controller, Rich solar panels, the solar isolator, the Victron DC to DC alternator charger, and then I'll round it out with some wire management tips. Also, check out my last video where I walk you through step by step on how to plan and install your pre-wires, which also includes information about wires and wire gauges that will help you to better grasp the information in this video. And be sure to hit the subscribe button down below so you don't miss my next video, which I will be explaining how my electrical system will function, followed by other videos like wiring my puck lights, outlets, appliances, and more. As usual, check the timeline of this video for time codes that will allow you to jump around to different sections, and check the description box for a link to EXPLORIST.Life's website. With that, let's get started. When it comes to electrical systems, they can be done very simple or complex, cheap or really expensive, built-in or portable. So be sure to consider your specific wants and needs before making any electrical decisions. Personally, I will be living out of my van full-time, so I wanted a system that was large enough to power various appliances, lights, and outlets for the normal conveniences you would find in a home. After months of researching what to buy, I finally purchased my main components from Battleborn, but soon after I received my order, I realized I wasn't even halfway done with researching and decision making because now I needed to connect all of the components together, which meant many more countless hours of research to follow and buying more material. So when I came across the EXPLORIST.Life wiring kits, I was beyond grateful. This box contains all the components of the EXPLORIST.Life All-in-One Wiring Kit, which includes everything I need to wire my entire electrical system. I mean it. It has the Victron Lynx distributor, 12 volt and 120 volt distribution panel, the master switch, all of the wires, wire lugs, heat shrink, ferrules, fuses, mounting hardware, and so much more. The great thing about the wires is they are properly sized to my specific setup, ensuring a safe and effective install. EXPLORIST.Life also includes a sheet of paper in the box that lists the gauge and length of wire provided for each part of the wiring process. The smaller items like wire lugs, ferrules, heat shrink, fuses, mounting hardware, and so forth all come in these tiny bags that are individually labeled so you know exactly what pieces go to what section of the electrical system. Having these components separated and labeled accordingly, and having the wire reference sheet makes this kit very straightforward. Not to mention, when you order their wiring kits online, they offer a range of wire sizes and variations that you can choose from depending on your specific application, and you can buy individual wiring kits for each section of the electrical install, like the battery bank wiring kit, or the Victron Lynx distributor wiring kit, or the 12 volt DC distribution panel wiring kit if you don't need all the components you would get in the all-in-one wiring kit. Additionally, because EXPLORIST.Life sources these products themselves, they have excellent quality control and ensure that every component they are sending you are compatible with one another, which they themselves know because they've installed their own kits into multiple vans. This kit takes the guesswork out of the entire install, saves you countless hours of researching the topic yourself, running to the store to buy each individual little piece, and ordering online where you risk the quality and compatibility of the random items that you will purchase. EXPLORIST.Life has already done the legwork for you. They have analyzed every detail to ensure a safe and effective install. They have read and understand the manuals of all the components, which I don't know about you, but I rarely read manuals and definitely not as thoroughly as they have. They have provided extremely detailed wiring diagrams for you to follow. They have provided countless step-by-step articles and countless step-by-step YouTube videos sharing everything with you, from what tools to use, to how to choose the correct wire size, how to wire solar panels, teaching you about volts and amps, and more. So why try and reinvent the wheel when they have already done the work for you? It's a great investment. And the best thing about it is they are very competitively priced and offer free shipping on most orders. So why would you waste all that time researching and ordering each individual part for around the same cost as just ordering the kit from Explorist.Life? As you can tell, I truly love Explorist.Life, and I thank them for their countless resources and product offerings that they offer to people like you and I who are doing our own DIY camper van electrical install. Thank you, Nate, Steph, and team. Truly, you guys are the best. So be sure to check the description box below for a link to Explorist.Life's website, YouTube channel, and a few of my favorite resources they have created for you and I. Now it's time to get on with the install. I am so excited to show you guys. Let's do this.
Before jumping in and wiring all the components together, it is important that you take the time to think through the electrical layout and plan accordingly. I would recommend getting all the electrical components in your physical possession so you can move items around to determine the most efficient orientation. Also, it is crucial that you consider how everything will be wired together. Sure, your battery bank can fit here, and the distribution panel there, and the inverter here, but is it the most logical location in relation to how the components will connect together? You don't want wires running everywhere in a dozen different directions, entangled amongst one another, which can cause a safety hazard, make it challenging to service the system, and can add confusion during the install. After taking the time to plan my layout, I used tape to map it out in the box until I became familiarized with the system. I also took a video of the tape as reference during the install, if needed, and I'd recommend you do the same. Now that I know how my electrical system will be arranged, it is time to prep the box for permanent install. To start, I drilled holes for various wires to feed into the box, like the chassis ground wire, BMV 712 battery monitor data cable, solar wires, shore power wires, and all my 12 volt and 120 volt wires running throughout my van. To do so, I used a 1-inch and 2-inch hole saw with my drill, as well as a 5/16 inch drill bit to make these various holes in their proper locations. From there, I sanded the box, applied edge banding to the ugly plywood ends that would be visible in the van, painted the inside and outside of the box, and added a rubber tape with Gorilla Glue to the holes I drilled in the box to protect my wires. Stay tuned for a future video where I will share in more detail the process of sanding, edge banding, and painting all of my cabinetry. Next, I installed the box back in the van, fed all the wires into their designated holes, and screwed it down permanently to my subfloor. At this point, I made a board to hold my distribution panels in the box. I measured, cut, drilled pocket holes, sanded, edge banded, and painted the board before installing it with pocket holes and L brackets. Lastly, I installed an aluminum track to secure my battery bank in place. To do so, I bought 1-inch by 1-inch aluminum angle that will go on all 4 sides of my battery bank. To cut the aluminum, I use a miter saw and wood blade since the aluminum is a soft metal. I placed a board on the angled aluminum to help hold it in place while I cut slowly with the saw. Remember to wear eye protection as many metal shavings will fly into your face. To screw the aluminum track to the box, I drilled countersink holes along the side of the aluminum. The counter bit drill will allow the screws to sit flush to the aluminum, which means the batteries will also sit flush to the aluminum. At one end of the battery bank, I screwed 2 lashing straps under the aluminum with 10 by 3/4 inch wood screws. These lashing straps will be used to hold the batteries in place and secure it. Then I screwed down the other 3 aluminum sides and installed all 4 batteries in my battery bank. Make sure all the positive terminals of the battery bank, which are red and have a plus sign, are on the same side of the battery bank, and all the negative terminals, which are black and have a negative sign, are on the other side of the battery bank for easier, cleaner, and a safer install. At the other end of the battery bank, I screwed in 2 hooks to run the other end of the lashing strap through. Once that was completed, I tightened the lashing straps around the battery bank, followed by a good wiggle test to make sure the batteries weren't going anywhere. To finish, I ran the vacuum through the box to clean up any wood and aluminum shavings created during this process. Now that the box is ready to house my electrical system, I'm going to touch on the tools you'll need to measure, cut, strip, crimp, and heat shrink wires, as well as some handheld devices to use for your safety and to troubleshoot the system. Throughout the video, the process remains consistent when making wire connections. You will measure, cut, strip, crimp, and heat shrink wires. To measure wires, of course you can use a measuring tape or ruler, but personally I loved using this combination square, which you can set to a desired length, so you can just lay the wire against the tool and mark the wire insulation with a pencil. This is especially helpful because many times you will need to make the same measurement back to back, so this makes the process a lot quicker. Once the wire is measured, it needs to be cut. To cut wire that is 14 gauge to 22 gauge, I am using these 4-inch spring-loaded flush cutters. For wires up to 6 gauge, I am using these 8-inch diagonal cutters. For wire up to 2/0, I am using the Klein 63030 coaxial cutters, which also cut through 10-3 wire. And for the largest wires, like 4/0, I am using 12-inch cable cutters, which also cuts through the 6-gauge 3-conductor wire that runs from the MultiPlus to the breaker box. The longer handles give more leverage to cut through the thicker wire. Now, 4/0 wire can also be cut with the Klein 63030 coaxial cutters, but personally I found the 12-inch cable cutters to be easier. If I had to choose just one of these wire cutters to purchase for this install, it would be the Klein 63030 coaxial cutters, hands down. After measuring and cutting your wires, you will need to strip back the wire insulation to expose the bare copper wire, which allows you to insert that into a terminal or to crimp on one of the many different types of wire connectors. To strip wire, I am using these self-adjusting wire strippers, which are fast and easy to use for 22 gauge wire up to 10 gauge wire. And it can also strip flat multi-wire conductors up to 10-3 wire with 2 cuts. It also strips multiple wires at once, adding to its efficiency. For wires 6 gauge to 12 gauge, I am using these Klein wire strippers, but because I have the self-adjusting wire strippers, I only use these for the 6 gauge wires. Place the wire in one of the 4 slots provided, which are each labeled for the wire gauge you are stripping. Squeeze the handles to cut through the wire insulation, and then pull the insulation off. For big wire, you can use the Klein 63030 coaxial cutters by spinning the tool around the wire, applying just enough pressure to cut through the insulation. Or you can use this cable knife for 4 gauge to 4/0 wire. To adjust the blade depth, twist the circle on the bottom of the tool, then push the head of the tool up so you can feed the wire into it. Let go of the head so that it can squeeze down on the wire, and then twist the tool around the entire wire. This is nice to have if you are stripping multiple wires that are the same gauge back to back, because once you adjust it to cut through the thickness of the insulation, you can keep it set to that depth to strip the other wires. But in all honesty, I only use these to strip the 6-3 wire running from the MultiPlus to my 120 volt distribution panel, and I'm sure the Klein 63030 coaxial cutters could have stripped it as well. So it is not necessary, and is just another option I wanted to try out and share with you. Now, it is very important that you strip wire carefully to avoid cutting the stranded wire itself. You only want to score the insulation enough for you to rip the insulation off by hand. For stripping tools in this specific install, you can get away with just the Klein 63030 coaxial cutters and the self-adjusting wire strippers. Now that the wire is measured, cut, and stripped, it may need a wire connector crimped on the bare wire. Wire conductors include, but are not limited to, wire lugs, MC4 connectors, ring terminals, spade connectors, fork connectors, ferrules, butt splice connectors, and so forth. As you can see here, some connectors can be purchased insulated or non-insulated. I'd recommend insulated connections when possible, which are the connectors with the plastic covering that helps to keep connections secure and prevent damage. Also look for heat shrink activated connectors to seal off the connection from moisture. As you can see here, insulated connectors are color coded. A red connector is for 18 to 22 gauge, a blue connector is for 14 to 16 gauge wire, and a yellow connector is for 10 to 12 gauge wire. Make sure you are using the correct size connector on the correct wire gauge. For ring terminals, spade connectors, and butt splice connectors, 22 to 10 gauge, I have these ratcheting wire crimpers with a flat jaw so the insulated connector doesn't get damaged. The crimper has 3 sets of teeth that are color coded. Match up the color of the connector to the same colored set of teeth on the ratcheting crimper, and squeeze the handles to crimp down on that metal section of the connector. The crimper handles need to be squeezed fully in order for the tool to release itself. For 8 gauge wire to 4/0 wire, you need to crimp on wire lugs. To do so, I'm using this big crimper right here. To start, place the tool on a solid work surface, lift the handle, insert the wire lug with the top of the lug facing the thumb adjuster and the bottom of the lug facing the punch. Then, push down on the handle. This will drive the punch into the bottom of the lug and curve the top of the lug, making a strong connection that can withstand a very heavy force. To accommodate different size wire lugs, use a thumb screw to slide the mechanism to the correct gauge as indicated on the side of the tool. Now when it comes to ferrules, you can buy crimpers that crimp ferrules into square, hexagonal, or trapezoid shapes. This is helpful because for certain connections, like the MPPT charge controller, the receiving terminals are squared shaped, which would best accommodate a ferrule that is crimped into a squared shape. Now let's take a step back. A wire ferrule is a thin metal tube that slides onto your stranded wire. It can also be insulated like these ferrules right here. The purpose of ferrules is to clean up the wire ends, which allows for a safer and cleaner install because it prevents stray wires going into the wrong terminal and causing a short in the system. Simply place all the stranded wire ends into the ferrule, place the metal tube into the ferrule crimper, and squeeze the handles. Note that the ferrule gauge must be the same gauge as the wire, and the stripped wire end should run the full length of the ferrule. This ferrule crimper is good for wires 8 gauge to 12 gauge, and it came with a pack of ferrules that I was able to use for my 120 volt AC wires when wiring the distribution panel. The last thing I will say about ferrules is actually a direct quote from Nate at EXPLORIST.Life. He says that a ferrule is a tool and not a necessity. So if it is hindering more than it is helping, it does not need to be used. You will see during the install, there are times when I used ferrules and times when I did not. Many times I did not use the ferrules provided because they were 6-gauge ferrules, and unfortunately, this ferrule crimper tool does not accommodate 6-gauge ferrules. Other times, ferrules were not used because it added too much bulk, or it didn't fit in the terminals, so I opted for bare wire instead. The last crimper I'll mention is specific for MC4 connections made on your solar panel wires. It has a tooth design that folds the metal connector into itself, making a tight crimp. When crimping any connection, make sure the wire is fully in the lug and doesn't fall out during the crimp, and make sure all the stranded wire is in the connector to prevent a safety issue. To easily add the wire into a connector, simply twist the stranded wire ends together and slide it into the connector. Also, for a wire run with a wire lug on both sides, make sure the wire lugs are facing the same direction for an easier installation. For crimping connections throughout this install, you will need all the crimpers that I mentioned. To finish the connection, use a heat gun to melt the heat-activated adhesive on the heat shrink so it conforms to the barrel of the wire lug or ferrule and the wire itself. Once you see glue coming out of both sides, you know it is applied correctly. This seals off the connection from moisture and can help strengthen the bond. With the EXPLORIST.Life wiring kits, they provide heat shrink that does fit over the wire lugs, so you can add the heat shrink itself to the wire after a wire lug has been crimped onto it. But if this was not the case, you would want to put the heat shrink on the wire before crimping on a wire lug. After you have measured, cut, stripped, crimped, and heat shrinked your wire, wipe down all the wire lugs with rubbing alcohol and a cloth to clean up any dirt and grime buildup to provide a better electrical connection. Now I will touch on 2 devices that are essential for your safety, to troubleshoot the system, and to test for reverse polarity. These 2 devices are a multimeter and an AC voltage detector. The multimeter serves several functions, but for this install I will be using it to test voltage throughout my install. The multimeter comes with 2 test leads, a black one that always goes into the negative or COM labeled port of the multimeter, and a red one that is positive and goes into the input or the port labeled for whatever you are testing for on the multimeter. The V with a straight line above it is for DC voltage, which can be used to test the voltage of a battery or solar panel. And the V with a squiggly line above it is for AC voltage, which can test the voltage of a standard household outlet. To turn it on, turn the dial to what you are testing for. In this case, I will turn it to V for voltage. Once turned on, don't let the 2 test leads come in contact with one another, and do not touch the metal prongs of the test leads when measuring voltage, because you will get shocked at that voltage, and personally, I have no desire to learn what 120 volts would feel like. Not only does this device tell you the voltage, but it also tells you what is positive and negative. See here, I am placing the red test lead to the red terminal on my battery, and the black test lead to the black terminal of the battery, and it tells me a voltage. Note that even though my batteries are 12 volts numerically, the battery and other items can vary slightly, and a 13 to 14 volt reading is pretty common. Now, if I switch the test leads to go on the opposite colors, black to red and red to black, you will still get a voltage reading, but it will have a negative sign at the start, which indicates reverse polarity. Now the AC voltage detector is pretty straightforward. If it comes in contact or even near 120 volt current, it beeps to let you know not to touch that connection. The last tool I would recommend for this install is a label maker. A label maker is important for labeling the breakers and fuses in the distribution panels, so you know what the wire run is for. Also, you'll want other tools and material handy, which includes, but is not limited to, a 1/2 inch, a 9/16 inch, and a 5/16 inch wrench and sockets, a torque wrench, small and large flathead and Phillips head screwdrivers, a drill, an impact driver, hole saws, needle nose pliers, a 1-inch step bit, 3M VHB double-sided tape, Rust-Oleum Stop Rust Clean Metal Primer and protective enamel, foam brush, and so forth.
Hopefully you found this section to be helpful. I will be linking all of those tools down below in the description box for you to go and purchase. And yes, I know the cost of tools can add up very quickly, but these are really critical so you can make good, solid, long-lasting connections that aren't going to cause a safety issue, that you won't have to troubleshoot your entire system to find that one bad connection. And honestly, it's just going to make this whole process go by a lot smoother if you have the right tools. So do it right the first time so you don't have to worry about it down the road.
Now that you know what tools are needed for this install, I want to quickly cover 5 FYIs to help you throughout the install, then we will begin wiring the system. Number 1, the wire gauge is almost always printed on the wire insulation, along with other information like the temperature rating and type of wire. So when you are referencing the paper in the EXPLORIST.Life All-In-One Wiring Kit, you can be sure you are choosing the right wire to work with. Number 2, the wire lug sizes are imprinted on the wire lugs. The first number will be the wire gauge it is meant for, and the second number will be the diameter of the hole on the lug for a bolt to fit into it. So this 4/0 by 5/16 inch wire lug means it goes on 4/0 wire and will fit on a 5/16 inch bolt. Number 3, when you fasten any connection with a wire lug, the wire lug must be making direct contact to the electrical component. For example, never ever put a washer between a wire lug and another electrical component like a battery terminal or the Lynx distributor bus bars, because the washer will interfere with the flow of electricity and end up melting things in your system. Also, note that the lock washers will always be placed below the head of a bolt or before a nut, with a washer on the other side to protect the wire lug or other electrical terminal. Additionally, all the connections in this install has a recommended torque spec listed by the manufacturer that should be followed for every connection. Torque specifications ensure a safe and effective install. If a connection is too tight or too loose, it can cause unwanted and unsafe heat, which could melt components or start a fire. Also, when you add the mega fuses to the Lynx distributor, remove all the hardware on the middle stud except the last piece, which is a nut. The mega fuse will rest on top of that nut. Number 4, if you purchase Victron Bluetooth components, download the Victron Connect app, which will allow you to monitor and control components of your electrical system via Bluetooth when you are in range. Also, I would highly recommend reading through the Victron Wiring Unlimited book, which I have linked below because it has a lot of great information. Lastly, number 5, I would highly recommend ordering the main components directly from Battleborn because they will program your entire system before sending it to you, so you can ensure everything is set to the correct parameters and you don't need to figure it out on your own. And a couple bonus FYIs, because why not? Make sure whenever you are installing your electrical system, there is good ventilation to prevent the units from overheating. To achieve this, drill holes in the enclosure, install a vent, or install a 12-volt fan inside the enclosure that you can turn on. And lastly, when you feed wires into a terminal, make sure there is no wire insulation in a terminal, which will affect the electrical connection and can potentially melt the connection due to added heat. And do not have bare, uninsulated wire outside of the terminal, which can cause a safety concern like electrocution and a short circuit. Now that you have those FYIs to reference, it's time to wire the battery bank. My battery bank will consist of 4 100 amp, 12 volt, lithium deep cycle batteries that I purchased from Battleborn. To wire the batteries together, I am using the EXPLORIST.Life Battery Bank Wiring Kit, which includes everything you need to wire up to 6 batteries with 4/0 wire. It includes 5 feet of red 4/0 wire, 5 feet of black 4/0 wire, 20 4/0 by 5/16 inch wire lugs, 10 pieces of black 1-inch heat shrink, and 10 pieces of red 1-inch heat shrink. To start, measure and cut 7-inch long pieces of wire from each 5-foot section of red and black 4/0 wire. This is a good length of wire to connect one 100 amp Battleborn battery to another 100 amp Battleborn battery when they are positioned side by side. Since I have 4 batteries, I only need 3 black and 3 red 7-inch 4/0 wires. EXPLORIST.Life intentionally provides extra wire in this kit in case you are using different batteries or a different wiring configuration. Next, strip back 7/8 of an inch of insulation on both ends of the 7-inch wires. Then, crimp the 4/0 by 5/16 inch wire lugs onto the ends of each wire. Once the lugs are crimped securely on the wire ends, add the adhesive heat shrink to both ends with a heat gun. Now that the wires are cut, stripped, crimped, and heat shrink together, it's time to clean off the wire lugs and battery terminals with rubbing alcohol and a cloth to remove any dirt or grime buildup to provide a better electrical connection. Finally, bolt everything together with the hardware included with each Battleborn battery, which includes stainless steel bolts, washers, and nylon nuts, which help to reduce the chances of the connection becoming loose. You will notice that the hardware includes 2 longer bolts and 2 shorter bolts. Personally, I use the 2 shorter bolts. Focus on wiring one side of the battery bank first before wiring the other side. The red wire goes on the red positive battery terminals, and the black wires go on the black negative battery terminals. The install goes bolt, washer, battery terminal, wire lug, washer, and nylon nut. After hand tightening the bolts and nuts, go back through and tighten all the connections. If you have a torque wrench, bring the connections up to Battleborn's recommended torque spec of 11 foot-pounds. Every battery manufacturer has their own torque specifications, so if you are using a different brand, be sure to check the manual for direction. For battery terminals that get 2 wire lugs, both lugs should go on the same side of the battery terminal, so the current can easily go from one wire to the other instead of having all the power jump through the terminal. Also, be sure the wire lugs are flat to one another and the terminals. Any gaps will create unwanted and unsafe heat. There are 4 correct ways to connect Battleborn batteries according to the Victron Wiring Unlimited book, but this configuration tends to be the easiest and cleanest. Now that the battery bank is wired, it's time to connect that to the Victron Lynx distributor. Here are the components needed for this part of the install: the Victron Lynx distributor, Victron BMV712 battery monitor, and the EXPLORIST-Life Lynx distributor wiring kit, which includes 5 feet of red 4/0 wire, 5 feet of black 4/0 wire, 4 4/0 and 5/16 inch wire lugs, 2 4/0 and 3/8 inch wire lugs, 4 1-inch red heat shrink, 2 1-inch black heat shrink, 1 18 to 22 gauge butt splice connector, a pair of Lynx adapters, a Blue C master battery disconnect switch, a 400 amp ANL fuse, a Blue C ANL fuse holder, shunt and switch spacers, and assorted screws to mount the Lynx distributor, shunt, master disconnect switch, and ANL fuse holder in place. To start, grab the shunt from the Victron BMV 712 battery monitor box and the shunt mounting hardware from the EXPLORIST.Life Lynx Distributor Wiring Kit. Temporarily mount the shunt in place to take a measurement with the negative black 4/0 wire that will run from the shunt to the furthest negative battery terminal, since wires exiting the battery bank should be on opposite ends of the battery bank. Make a mark on the wire so you know where to cut. Then, cut, strip, crimp, and heat shrink a 4/0 by 5/16 inch wire lug onto the end of the wire that will attach to the battery bank, and a 4/0 by 3/8 inch wire lug onto the end that will attach to the shunt. Next is the positive wire that goes from the battery bank to the Lynx distributor. Before the positive wire gets to the Lynx distributor, it has to go through the main system fuse as well as the main battery disconnect switch. So I started measuring, cutting, stripping, crimping, and heat shrinking lugs onto the 4/0 wire. The battery end and A&L fuse connections get a 4/0 by 5/16 inch wire lug, and the end connecting to the battery disconnect switch gets a 4/0 by 3/8 inch wire lug. It is important that both of these wire runs have an identical linear distance from one side to the other, taking into account the fuse, shunt, and master switch, so that the battery bank drains and charges evenly. Next, clean all the wire lugs with alcohol and a cloth. Then, it's time to begin mounting and connecting all the components. When mounting the shunt, the orientation of the unit does indeed matter. There is a battery side and a load and charger side of the shunt, as indicated on the side of the unit. Mount the load and charger side in the direction of where the Lynx distributor will be mounted for connection later. Remember to apply the shunt spacers between the shunt and wall. Once the shunt is mounted, connect the negative wire with a 3/8 inch wire lug to the battery side of the shunt in the order of bolt, lock washer, washer, wire lug, then shunt. Then connect the other end of the negative wire to the furthest negative battery bank terminal by loosening the current connection and adding the wire lug flat against the other lug for a solid and safe electrical connection. Thus, it will go bolt, washer, battery terminal, battery negative wire lug, shunt negative wire lug, washer, lock washer, and nut. Clean up the connection by adding zip ties to the negative wire run from the shunt to the negative wires connecting the battery bank. Then, add a Lynx adapter to the load and charger side of the shunt in the following order: bolt, lock washer, washer, Lynx adapter, then shunt. For the positive wire connection, remove the back cover on the master disconnect switch and loosen the two nuts with a 9/16 inch wrench. For the side of the switch that will connect to the Lynx distributor, add the Lynx adapter. On the other side, add the positive wire with a 3/8 inch wire lug that will run to the A&L fuse holder. You can ignore the input and output writing on the back of the master switch, as it does not matter what side you use for either connection. Then tighten the nuts back on and add the back cover to the switch. Next, loosen the nut on the fuse holder with a 1/2 inch wrench and add the 5/16 inch wire lug onto one of the outside studs, then tighten the nut back on. From there, use the A&L fuse holder mounting hardware from the EXPLORIST.Life Lynx Distributor Wiring Kit to secure the unit to the wall. To mount the disconnect switch, use the long screws and spacers from the EXPLORIST.Life Lynx Distributor Wiring Kit Remember to put the spacers between the switch and wall. The spacers for both the switch and shunt help to push the unit off the wall enough to sit flush with the Lynx distributor bus bars for a seamless connection to the Lynx adapters. On the opposite end of the fuse holder, add the other positive wire's 5/16" wire lug, then run the opposite end of the wire to the nearest positive battery terminal. There will likely be excess wire because, as I mentioned earlier, the linear distance of the positive and negative connection needed to be identical. So just coil up the excess wire to keep it semi-organized and out of the way. Then I prepared the Lynx distributor for mounting by removing the black and red end caps over the bus bars and unscrewing the lid to expose the 4 mounting points to fasten the unit to the wall, with the Lynx distributor mounting hardware from the EXPLORIST.Life Lynx Distributor Wiring Kit. Once mounted, connect the Lynx adapters to the Lynx distributor. The shunt Lynx adapter goes to the negative bus bar of the Lynx distributor, and the master switch Lynx adapter goes to the positive bus bar of the Lynx distributor. The order will go bolt, washer, Lynx adapter, Lynx distributor, washer, lock washer, and nut. Tighten the connection with a 1/2" wrench and socket. Now it's time to grab the power wire from the BMV 712 box to wire it to the Lynx distributor and shunt. This wire will power the computer board on the shunt for the BMV 712 battery monitor that also sends power to the display gauge. Use a 5/16" wrench or socket to loosen the Lynx distributor hardware on the furthest top right stud. Then, connect the ring terminal end of the wire to that stud. Connecting it here will allow the power to the BMV 712 to be disconnected when the main system switch is turned off. If you want the BMV 712 to stay on all the time, you'll want to connect this wire somewhere on the battery side of the switch. Personally, I like the option of being able to turn off the entire system with no loads running, and that is why I am wiring it this way. Refasten the washer, lock washer, and nut to the stud over the ring terminal with the 5/16" wrench or socket. As you can see, this power cord is way too long for this application, and that is why EXPLORIST.Life has included the butt splice connector in their Lynx distributor wiring kit, so the wire can be cut down to a more appropriate length. Cut the power cord after the fuse, which is this black object, then strip the wire end, and crimp on the butt splice connector. Repeat those steps on the other half of the wire that was cut and finish by heat shrinking the butt splice connector. From there, I ran the power cord through the Lynx distributor and plugged the ferrule end into the B1 terminal of the shunt, which is the terminal closest to the battery side of the shunt. Next, grab the white data cable in the BMV 712 box, connect one end to the shunt, and the other end to the back of the battery monitor display, which is also found in the BMV 712 box. To mount the monitor, use a 2 1/8" hole saw to drill a hole in the wall or cabinetry that you plan on mounting it to. Slide the monitor into the hole and screw the back ring back on the monitor to secure it in place. A faceplate is also provided with the unit if you'd like to use that as well. Lastly, bolt the 400 amp main fuse onto the 2 inside studs of the fuse holder. Then, you can turn on the master battery switch, which will send power to the BMV 712 battery monitor display.
Oh my gosh, we have power! Oh my gosh, that's so cool! Oh my goodness!
At this point, open the Victron Connect app, update the Smart BMV firmware, and change the parameters to match your system. To finish, I fastened the Lynx distributor cover back into place and added the fuse holder cover on after bending one of the side flaps off for my wire to fit underneath it. Now that the battery bank is wired to the Lynx distributor, it is time to connect the chassis ground from the body of the van to the Lynx distributor. For this section of the install, I am using the EXPLORIST.Life Chassis Ground Wiring Kit, which includes 5 feet of black 4/0 wire, 2 4/0 by 5/16 inch wire lugs, 2 1-inch black heat shrink, a 5/16 inch 18 thread by 1 inch hex bolt, a 5/16 inch 18 thread hex nut, and a 5/16 inch flat washer, lock washer, and serrated washer. The chassis ground must be connected to the metal body of the van. You can achieve this by drilling a hole into a body support rib with a 5/16 inch drill bit, or by using holes already provided in the van. I am using this hole built into the rib of my ProMaster's wheel well. Therefore, I made this part of the connection prior to permanently installing the electrical box. To begin, cut, strip, crimp, and heat shrink the 4/0 by 5/16 inch wire lugs onto both ends of the chassis ground wire, and wipe down the wire lugs with rubbing alcohol and the cloth. To install the wire lug to the body of the van, it goes bolt, washer, wire lug, serrated washer, van body, washer, lock washer, and nut. Then tighten the connection with a 1/2 inch wrench and socket. It is important that this connection is touching the bare metal of the van. That is why EXPLORIST.Life provides a serrated washer which helps to cut through the van paint. Otherwise, you'd have to scrape the paint off of the van in that specific location before making the connection. From there, I fed the chassis ground wire into its designated hole on the electrical box and bent it up to connect it to the front of the Lynx adapter, where it connects to the negative bus bar of the Lynx distributor. The order goes bolt, washer, wire lug, Lynx adapter, Lynx distributor, washer, lock washer, and nut. Then tighten the connection with a 1/2 inch wrench and socket. The purpose of this connection is to provide a return loop back to the battery bank to complete the circuit and blow the main fuse if there is a direct short with the chassis, thus protecting the electrical system. Therefore, according to ABYC standards, the chassis ground wire can be no smaller than 1 size smaller than the biggest wire in the entire system. Since the other connections are using 4/0 wire, this means the chassis ground could be no smaller than 3/0. But, as EXPLORIST.Life shares, they provide 4/0 for the sake of consolidating wires and lugs. Now that the chassis ground is wired to the Lynx distributor, it is time to wire the Victron MultiPlus Inverter-Charger to the Lynx distributor. For this part of the install, I have my Victron MultiPlus Inverter-Charger that I purchased from Battleborn, the Victron VE Bus Smart Dongle, and RJ45 UTP data cable from EXPLORIST.Life, and the EXPLORIST.Life MultiPlus wiring kit, which includes 4/0 red wire, 4/0 black wire, 6 4/0 by 5/16 inch wire lugs, 2 1-inch red heat shrink, 4 1-inch black heat shrink, a 400 amp mega fuse, and the Inverter-Charger mounting screws. Begin by mounting the MultiPlus backer plate to the wall with the 5 wood screws from the EXPLORIST.Life MultiPlus wiring kit. Then, hang the MultiPlus by lining up the lip on the back of the unit to the flared tabs on the backer plate. Push the unit down to make sure it is completely on the plate. Then, use the 2 panhead screws from the EXPLORIST.Life MultiPlus wiring kit to screw in the bottom of the MultiPlus on the left and right side. Personally, I knew this would make a tight fit for me to add wires throughout the install if I mounted it now, so I secured the MultiPlus to the wall permanently after connecting all the wires to the unit. At this point, make sure the master battery disconnect switch is off, then remove the Lynx distributor cover and the MultiPlus front panel to reveal the computer board. Also, pull off these black separator flaps on the Lynx distributor to just get them out of the way. They simply snap in and out of place. Then, measure, cut, strip, crimp, and heat shrink the 4/0 wires that will go from the Lynx distributor to the MultiPlus. This includes a positive wire, a negative wire, and an equipment ground wire, all of which have 4/0 by 5/16 inch wire lugs. Clean the wire lugs with a cloth and rubbing alcohol. Connect the equipment ground wire to the stud on the bottom of the MultiPlus Inverter-Charger with the order going MultiPlus, serrated washer, wire lug, washer, lock washer, and nut, and tighten the connection with a 9/16 inch wrench or socket. Then, connect the positive and negative wires to the positive and negative battery studs on the Victron MultiPlus Inverter-Charger. Remove the hardware from the studs, feed the wire up the bottom opening of the MultiPlus, and add the wire lug and hardware back on the stud in order of MultiPlus, lug, washer, lock washer, nut, and tighten the connection with a 9/16 inch wrench or socket. The other end of the equipment ground wire will go on the center stud of the negative bus bar in the Lynx distributor. After removing the stud hardware, you will notice a ring terminal on the stud that is part of the Lynx distributor. Remove the ring terminal before adding the equipment ground wire lug in direct contact with the negative bus bar. So the order will go Lynx distributor negative bus bar, equipment ground wire lug, ring terminal, washer, lock washer, and nut, and tighten the connection with a 9/16 inch wrench or socket. The other end of the negative wire will go on the leftmost stud of the Lynx distributor's negative bus bar. Remove the stud hardware, add the wire lug directly to the negative bus bar, and refasten the washer, lock washer, and nut, and tighten the connection with a 9/16 inch wrench or socket. Remove the hardware on the two studs directly above the negative wire. Add the 400 amp mega fuse to those two studs after cleaning it with rubbing alcohol. Then add the other end of the positive wire on top of the fuse on the lower stud that the fuse is resting on, and refasten the washer, lock washer, and nut with a 9/16 inch wrench or socket. Now it's time to wire the VE bus smart dongle to the MultiPlus so I can turn the unit on and off from my phone and set proper shore power input current limits when I'm in Bluetooth range. Using a tiny, and I mean tiny, flathead screwdriver, secure the red wire ferrule to the battery positive terminal and the black wire ferrule to the battery negative terminal of the VE bus smart dongle. Then, connect the positive wire lug to a positive terminal of the Victron MultiPlus and the negative wire lug to a negative terminal of the MultiPlus. And if you haven't caught on yet, it goes MultiPlus, wire lug, washer, lock washer, nut, and tighten with a 9/16 inch wrench or socket. Plug one side of the RJ45 UTP cable into the VE bus smart dongle. Wipe down the bottom of the MultiPlus with a cloth and alcohol. Pull off the double-sided tape cover on the bottom of the VE bus smart dongle and stick it to the bottom side of the Victron MultiPlus. Feed the other end of the RJ45 UTP cable up into the MultiPlus and plug it into one of the two VE bus ports on the far left side. At this point, go ahead and turn on the master battery disconnect switch to deliver 12-volt DC power to the MultiPlus. Then, turn the MultiPlus switch up to on. You should hear the MultiPlus kick on and see a green light. Now open your Victron Connect app, click on the VE Bus Smart Device, which is the MultiPlus Inverter-Charger, update the firmware if necessary, and then you will see you are connected and that the inverter is converting 12-volt DC to 120-volt AC. You can use the app to turn the MultiPlus off and on, as well as set the shore power input current limits, which tells the MultiPlus what amperage of shore power that you're connected to, so that the MultiPlus doesn't pull more than that preset amount so you won't accidentally trip the shore power breaker. The MultiPlus will pull any overages from the battery bank. This is called Power Assist. Now, because I purchased everything from Battleborn, they already programmed my entire system for me. But if you need to program your MultiPlus, you'll need to use a Victron MK3 USB dongle that you'll connect to a laptop or an Android phone, and the end of the RJ45 UTP cable that was plugged into the VE Bus Smart Dongle to set up your system on the Victron Connect app. You will see a MultiPlus option appear on the app that you'll then click and use the password ZZZ if and only if you are a trained Victron professional. Now that the Victron MultiPlus Inverter-Charger is wired to the Lynx distributor, it is time to wire the MultiPlus to the 120-volt AC distribution panel. Here are the components used in this section of the install. The 120-volt AC distribution panel from EXPLORIST.Life and the EXPLORIST.Life 120-volt AC distribution panel wiring kit, which includes 6-gauge triplex wire, 6 6-gauge insulated ferrules, 1 1-inch black heat shrink, a 50-amp square D-Home main breaker, a wire gland, and screws to mount the panel. Before getting started, make sure the master battery disconnect switch and MultiPlus is turned off. You can test the MultiPlus with the multimeter or 120-volt detector to make extra sure it is safe to work on. To start, strip back 4 inches of the 6-3 wire sheath and remove the added strings in the coil, leaving just the black, green, and white wire. Then, add 1-inch black heat shrink to the wire to clean up the edge and add some protection. Next, remove the center wire gland from the MultiPlus to add it to the 6-3 wire. Add the bottom of the wire gland to the 6-3 wire first, then the middle section of the gland. Screw the two pieces together, leaving no gaps. You will feel resistance because the teeth of the middle section of the wire gland are being pinched inward to make a tight connection around the wire. You may need to grab some vice grips to tighten it completely. Then, measure, mark, and strip back about 5/8 of an inch on all 3 wires, and crimp on a 6-gauge insulated ferrule onto each wire end. It is crucial that these 3 wires are the same exact length for installation in the MultiPlus terminals. Having the wires at different lengths will make it challenging and potentially impossible to add all 3 wires properly. Feed the 6-3 wire and wire gland back into the MultiPlus and add the top piece of the wire gland back over the wires and screw it onto the middle part of the wire gland to help hold everything in place for the time being. Using needle nose pliers, guide the 3 wires into place. The black wire into the line terminal, white wire to the neutral terminal, and green wire to the ground terminal. Once the wires are in the terminals, tighten the terminal screw with a Phillips head tool. Finish tightening up the wire gland by hand the best you can. Then I carefully use a flathead screwdriver to continue tightening the connection. Now it is time to prep the 120-volt AC distribution panel. Flip the unit over and use a box cutter to cut away the large hole. Fasten the wire gland from the EXPLORIST.Life 120 volt AC distribution panel wiring kit into the hole. Start by hand tightening the connection and finish with a vice grip to make sure it is installed all the way. From there, stretch the 6-3 wire from the MultiPlus to the 120 volt AC distribution panel area. Cut it to length, strip back the sheath, remove the extra string in the wire coil, and add a 1-inch black heat shrink to the wire edge to clean up the cut. This heat shrink was left over from the battery bank kit, but isn't necessary if you don't have any leftovers like I did. Then feed the 6-3 wire into the cable entry gland of the distribution panel and feed your 120 volt AC branch circuits that you ran during pre-wiring into the distribution box. All the branch circuit wires are labeled accordingly, so I know which wire run is for which circuit of outlets. At this point, I took a picture of the wires in the distribution box, so I'd have that to reference when it came time to label each breaker. At this point, I stripped back the insulation for each triplex wire. You'll notice this breaker box has 2 sides. For this application, we will only be using one side, as the other side is reserved for campers with 50 amp shore power service with 2 hot legs incoming, or for powering circuits from the MultiPlus AC out to, which is for circuits only powered when shore power is connected. Then, I inserted the 50 amp Square D Home main breaker. On the back bottom of breakers, there is a notch that will sit on the middle lip of the distribution panel, and a slot on the back top of the breaker to slide onto the positive busbar post of the distribution panel. Simply line up the bottom of the breaker first, then tilt the breaker up to secure the top half to the positive busbar post. Grab the securing bracket that is taped inside the distribution panel and screw it into place with a screw from the EXPLORIST.Life 120 volt AC distribution panel wiring kit to the top of the breaker box. Part of the bracket will lay on top of the main breaker to help hold it in place. Then, I begin stripping and crimping ferrules onto all the triplex wire ends for my outlets. Again, the ferrule crimping tool I purchased came with a pack of ferrules, so I used those to clean up the wire ends and to prevent a short in the system. Ferrules aren't a requirement, so if you don't have any, just twist the ends of your wires and make sure all the stranded wire goes in only one terminal to prevent a short in the system. I focused on the green wires first, which go into the ground bus bar in the back of the distribution box, and then the white wires that go into the neutral bus bar at the front of the distribution box. Focusing on one color at a time helps to stay organized. Then, I stripped and crimped the black wires to feed into the bottom of their respective breakers. Since only one side of the distribution box can be used for this application, I purchased tandem breakers, which allows me to have up to 8 total circuits, since tandem breakers are designed to allow 2 120 volt circuits on the same breaker. 8 120 volt circuits should be plenty for any van build. These 20 amp Square D Home tandem breakers can be purchased separately from EXPLORIST.Life. The black wire ferrules will go into the respective breaker terminals on the bottom. Simply apply the ferrule in the terminal and fasten the screw. Lastly, strip and crimp the 6-gauge insulated ferrules from the EXPLORIST.Life 120 volt AC distribution panel wiring kit onto the ends of the 6-3 wires. Since I didn't have the right crimping tool for 6-gauge ferrules, I decided to skip the ferrule and use the bare metal wire for my connection. But if you have the right tool, I definitely recommend using the ferrules provided. Again, the green wire goes on the ground bus bar in the back, the white wire goes to the neutral bus bar in the front, and the black wire goes into the 50 amp main breaker. Now the distribution box and distribution panel lid can be screwed down with the hardware provided in the EXPLORIST.Life 120 volts AC distribution panel wiring kit. To start, add screws around the perimeter of the distribution box, except for the four corners. For the distribution panel lid to sit flush to the distribution box, remove some of the back covers on the lid where you have breakers. To do so, I use the Klein 63030 coaxial cutters. Simply line the tool up on the crease and squeeze. The black piece should pop right off. Now the lid will sit flush on the distribution panel box, and the holes on the four corners of the lid will line up with the four holes in the corner of the distribution box. Apply the screws in each corner. To open the lid, push down on the little window and it will pop open, giving visibility to the main breaker and each circuit breaker. Grab the label maker and create detailed labels for each breaker, indicating what that breaker is powering. Now it is time to test a 120 volt AC circuit. To do so, I wired an outlet, plugged in a phone charger to the outlet, turned on the master battery disconnect switch, turned on the MultiPlus, turned on the 120 volt 50 amp main breaker, and the 20 amp 120 volt breaker for that specific wire run. And we have power! Now that the 120 volt AC distribution panel is wired to the MultiPlus, it is time to wire for shore power. For this section of the install, I am using the EXPLORIST.Life 30 amp shore power wiring kit, which includes 10 gauge triplex wire, 3 10 gauge ferrules, a 30 amp shore power inlet, and the mounting hardware of 4 number 8 by 1 inch stainless steel machine screws, number 8 stainless washers, and number 8 stainless nylock nuts. I also purchased the 30 amp shore power cord and 15 amp to 30 amp adapter from EXPLORIST.Life.
So first step for your shore power is determining the location. I know that I want to put it on the driver's side wall in the very back next to my electrical box so that the wires can easily feed into my electrical system that this will be housing. So you got to make sure that you're considering both what's on the inside of your van and the outside of your van, meaning there's trim on the outside of your van. Do you want to drill through that? There's flaps right here on the inside of your van you don't want to drill through or hit, so you got to really make sure that you're choosing a good location. So I've decided to put my shore power right here, and what I've been noticing is that this lip right here on the van that's above this black vent, this is where the trim on the outside of your van stops. And then you can feel a little bit indent as you go up more. You can also see that indent on the outside of your van as well. So I'm aiming to get it between that so it's on a nice flat and smooth surface. As you've seen me do in previous videos, I always use painter's tape when cutting into the metal, just so I can protect my van from any scratches, from any paint peeling off and things like that. So go ahead and tape up that area that you're going to be drilling your hole for your shore power in. And like I mentioned earlier about the trim piece and the edge on the inside of your van, this is what I was talking to, is this black section. So where that lip is this line right there. So again, I'm putting it above that, but below this indent on the wall. So right here. I am using a 1/8 drill bit to drill from the inside of my van to start with a pilot hole exactly where I want the shore power. Reason I'm doing it on the inside is so I know that it's not going to be hitting or being obstructed by anything already on the inside of my van. And I'm going to be holding a vacuum hose up while I do that hole just to catch any small metal shavings that are going to be created from this pre-drill so that it's not loose in my van, causing rust. Now I'm going to tape a cardboard box to the outside of the van just to catch those metal shavings when I go to drill with the hole saw. And I'm also taping a box on the inside of the van, again, to catch those metal shavings. Metal shavings loose in your van are not good. They will cause rust, so you want to make sure that you don't leave any behind, and they are so small that they fly around and they move around, and then it's hard to clean them all up all the time. So that is why I always tape boxes to wherever I'm cutting into the van, just so I can try and catch those and eliminate them from going freely in the van. So now I'm using a 2 7/8 inch hole saw. Don't forget to wear your glasses, safety glasses, and then drill away.
Place the drill bit of the hole saw into the pre-drilled hole. The drill bit in the middle helps to keep the hole saw from jumping around. For a successful cut, keep the hole saw straight and level with little to no movement.
And now I'm just using some double-sided tape to hold this up on the van right here so that I can drill the pilot holes for the screws that go into this. And to make sure it's nice and level, you can measure on the van, so up to your trim piece, right there and right there. And that'll also help you to get nice and squared and leveled. Open it, and then you're going to pre-drill in those 4 corners with an 1/8 inch drill bit. And now you can take that off, and then I'm going to use a metal file to clean up these sharp edges. And now it's time for your Rust-Oleum Stop Rust Clean Metal Primer and your Rust-Oleum Stop Rust Protective Enamel that I find easiest to apply with a foam brush, keeping the paint here in the box on the inside just to catch any drips that might happen. So do the primer first, wait for it to dry for 15 minutes, and then do the protective enamel. Now I'm going to remove the tape and the cardboard box on the inside, vacuum up anything that might have fallen inside the van, and then we're going to start wiring the shore power.
Another place I see people install their shore power inlet is here on the black trim piece on the van bumper. This is where I wanted to install it originally, but I kind of forgot about it and just installed it on the side of my van, which isn't a big deal, but if I would have done it on the trim in the back, it blends into the van more instead of standing out like it does on mine. To begin wiring the shore power inlet, remove the retaining clip on the back cover. It is secured with 2 Phillips head screws. Then, feed the 10-3 wire through the back cover of the inlet. Next, strip back 2.5 inches of the triplex wire outer sheath and 3/4 inch off the end of the 3 individual wires. Because ferrules won't fit into the shore power inlet terminals, twist the ends of the bare stranded wires to feed it into the respective terminals. The terminals on the inlet are far enough apart that the chances of stray wires going from one side to the other causing a short is slim to none. Before adding the wires, unscrew the 3 retaining screws on the side of the shore power inlet to make sure the terminal is open to receive the wire. Now you can insert the 3 wires into the color-coded shore power inlet. The black wire goes into the black terminal, white wire to the white terminal, and green wire to the green terminal. To hold the wires in place, retighten the 3 wire retaining screws on the side of the shore power inlet. If you have an impact driver, the recommended torque spec for these screws is 20 inch-pounds. Make sure there is no wire insulation in the terminals, which would create a poor electrical connection. From there, slide the back of the shore power inlet up the wire. The side with the retaining clip area will face down. Then, refasten the retaining clip back into place. Now it's time to fasten the shore power inlet to the van. Carefully feed the 10-3 wire into the hole you drilled from the outside of the van. Then add the 4 1-inch stainless steel machine screws into the 4 corners of the shore power inlet. On the inside of the van, add the washers and nylon nuts to all 4 screws and tighten the 4 connections. An 11/32 inch socket worked for me. As you can tell, I did this part of the shore power install prior to permanently installing my electrical box. So before moving the box into place, I fed the triplex wire into its designated hole on the box. Now all that is left is to connect the other end of the 10-3 triplex wire to the MultiPlus. So strip back about 3 inches of the outer sheath and then strip about 1/2 inch of insulation on the 3 individual wires. Crimp the 10 gauge ferrules provided in the EXPLORIST.Life 30 amp shore power wiring kit onto each wire end. Remove the left cable entry gland on the bottom of the MultiPlus. Feed the bottom section and middle section of the cable entry gland over the 10-3 wires, and tighten the two pieces together. Feed the 3 wires and cable entry gland back into the left port of the MultiPlus bottom. Remember to add the top disc of the cable entry gland over the wires and screw it onto the bottom half of the cable entry gland. Start by hand tightening the connection, then carefully use a flathead screwdriver to tighten it further. Lastly, feed the 3 wires into the respective terminals. Black wire to the line terminal, white wire to the neutral terminal, and green wire to the ground terminal. Tighten the terminal screws with a Phillips head tool to secure the wires in the terminals. Now the shore power inlet is ready to be used. Turn on the master battery disconnect switch. Plug the 30 amp shore power cord into your van's shore power inlet and tighten the head of the cord around the inlet, which secures the cord in place. Then, plug the 30 amp shore power cord into a 30 amp shore power inlet at a campground. If you are plugging into a standard 15 amp household outlet, use the 15 amp to 30 amp adapter to do so. Open the Victron Connect app and turn on the MultiPlus Inverter-Charger. Now you should see the MultiPlus start charging. The shore power will charge your batteries and power the 120 volt loads running in the van. Any leftover power will go on to charge the batteries. Now that we can power our 120 volt loads directly from shore power and charge our 12 volt DC battery bank from 120 volt shore power, it's time to wire the 12 volt DC distribution panel. Here are the components for this part of the install: the 12 volt DC distribution panel from EXPLORIST.Life and the EXPLORIST.Life 12 volt distribution panel wiring kit, which includes 6 gauge red wire, 6 gauge black wire, 2 6 gauge by 5/16 inch wire lugs, 2 6 gauge insulated ferrules, 1 1/2 inch red heat shrink, 1 1/2 inch black heat shrink, a 100 amp mega fuse, and the 12 volt distribution panel mounting hardware. To start, measure, cut, strip, crimp, and heat shrink the wires that go from the Lynx distributor to the 12 volt distribution panel. Both the positive and negative wires get a 6 gauge by 5/16 inch wire lug on one side and a 6 gauge ferrule on the other side. Clean both wire lugs with rubbing alcohol and a cloth to facilitate a better electrical connection. Make sure the master battery disconnect switch is off. Then, remove the Lynx distributor hardware from a remaining negative busbar stud. Connect the negative wire lug to the negative busbar of the Victron Lynx distributor, and replace the washer, lock washer, and nut, and tighten the connection with a 9/16 inch wrencher socket. Remove the Lynx distributor hardware on the 2 studs above the negative wire. Add the 100 amp mega fuse to those 2 studs after wiping it down with a cloth and rubbing alcohol. Then, add the positive wire lug on the lower stud that the fuse is resting on. Refasten the hardware on both studs, going washer, lock washer, and nut, then tighten with a 9/16 inch wrencher socket. Now stretch those 2 wires to the 12 volt distribution panel area for later, and begin wiring the 12 volt branch circuit wires that you have run through your van as part of your pre-wiring. Strip back about 8 inches of each wire's outer sheath, and then strip a 1/4 inch of insulation from each individual wire. The negative wires go on the negative bus bar, and the positive wires go on the positive bus bar. Each positive wire gets its own terminal, but the negative wires can share a negative terminal if needed. I am not using ferrules on these wires because it adds too much bulk. Remember what Nate says, ferrules are a tool and not a requirement, so if they are hindering more than they are helping, they don't need to be used. Instead, twist the wire ends and make sure each stranded wire is going in the proper terminal, and fasten each wire by screwing the terminal screw. Again, make sure there is no insulation in the terminal, which will affect the electrical connection. Now, if you need help determining what type and gauge wire you need for 12-volt branch circuits, check out my last video where I walk you through that process step by step. Also, keep in mind that the thickest wire you can use in this distribution panel is 10 gauge wire. Then, connect the negative and positive wires from the Victron Lynx distributor to their respective spots on the 12-volt distribution panel. Negative wire to the negative bus bar, and the positive wire to the positive terminal at the bottom. Again, I didn't use the 6-gauge ferrules because I don't have the proper tool, but if you do, definitely add the ferrules for those two connections. Then, the 12-volt DC distribution panel can be screwed into place with the hardware in the EXPLORIST.Life 12-volt DC distribution panel wiring kit. Now, add the ATC blade fuses to the front of the 12-volt distribution panel and their respective terminals. You will notice numbers along the side of each fuse holder, which references the numbers on the back of the 12-volt distribution panel bus bars. This will help you make sure that each fuse is going in the right place. To determine what size blade fuse to use in the 12-volt DC distribution panel, use the EXPLORIST.Life fuse calculator that I have linked below. You will need to know the amps of each 12-volt item you are powering off of your electrical system. Also, note that this 12-volt DC distribution panel requires only ATC fuses. I have linked the fuses I used below. Lastly, grab the label maker and make detailed labels for each circuit to go on the lid of the 12-volt distribution panel. The numbers on the lid refer to the fuse and bus bar numbers for reference. Slide the 12-volt distribution panel lid onto the 12-volt distribution panel box. To test the 12-volt wiring, turn on the master battery disconnect switch and test a 12-volt circuit.
Fingers crossed. It turns on. Oh my gosh. Oh my gosh. This is so cool.
Now that we have wired the 12-volt distribution panel, it's time to wire the system for solar charging. This step will consist of 3 separate sections. In this section, we will be wiring the Victron Smart Solar MPPT charge controller to the Victron Lynx distributor. Here are the components for this part of the install. The Victron Smart Solar MPPT 150 solar charge controller that I purchased from Battleborn, and the EXPLORIST.Life Victron Smart Solar MPPT 130 wiring kit, which includes 6-gauge black wire, 6-gauge red wire, 2 6-gauge ferrules, 3 6-gauge by 5/16 inch wire lugs, a 6-gauge by 1/4 inch wire lug, 2 1/2-inch red heat shrink, 4 1/2-inch black heat shrink, a 60 amp mega fuse, and the Victron Smart Solar MPPT mounting hardware. Now for the remainder of the video, you will see me wiring this 150 MPPT charge controller, but I have since purchased a larger MPPT charge controller rated 150/45 because my solar panel wattage was too high for the 150. Now I could have rewired my solar panels in parallel and the 150 MPPT charge controller would have worked, but I didn't want to do that, so I just upgraded to a bigger charge controller. It is the same exact install process, so back to the video. To start, measure, cut, strip, crimp, and heat shrink a 6-gauge by 5/16 inch wire lug and a 6-gauge by a 1/4 inch wire lug onto the ends of the black equipment ground wire that will connect the MPPT charge controller to the MultiPlus. Remember to clean the wire lugs with rubbing alcohol and a cloth. Connect the 1/4-inch wire lug on the equipment ground wire to the stud on the side of the MPPT charge controller with a Phillips head tool in order of bolt, lock washer, washer, wire lug, serrated washer, and charge controller. Next, use the four 14 by 3/4 inch panhead screws from the EXPLORIST.Life MPPT charge controller wiring kit to mount the charge controller in place. Now the other end of the equipment ground wire needs to be connected somewhere with a clear path back to the negative bus bar of the Lynx distributor. Since all the spots on the Lynx distributor are taken, connect the equipment ground wire from the MPPT charge controller to the bottom stud of the MultiPlus. You may recall we already wired an equipment ground wire to this stud when we were connecting the MultiPlus to the Lynx distributor. So, this stud will share the two wire lugs. Simply remove the nut, lock washer, and washer, put the 6 gauge by 1/4 inch wire lug from the MPPT charge controller equipment ground wire on top of the equipment ground wire lug already on the stud, and reapply and refasten the washer, lock washer, and nut with a 9/16 inch wrencher socket. To finish wiring the MPPT charge controller, measure, cut, strip, crimp, and heat shrink the red and black power wires that will connect the charge controller to the Lynx distributor. Both wires will have a 6 gauge by 5/16 inch wire lug on one end and a 6 gauge ferrule on the other end. Wipe down the wire lugs with alcohol and a cloth to aid in a strong electrical connection. Then, remove the Lynx distributor hardware on the next set of 3 studs in the Lynx distributor. Add the negative wire lug to the negative bus bar of the Lynx distributor, and refasten the washer, lock washer, and nut with a 9/16 inch wrencher socket. Next, add the 60 amp mega fuse to the 2 studs above the negative wire after cleaning it with rubbing alcohol and a cloth. Add the positive wire lug on the bottom stud that the fuse is resting on, and refasten the washer, lock washer, and nut with a 9/16 inch wrencher socket on both studs. Connect the other end of the positive and negative wires to the positive and negative battery terminals on the bottom of the MPPT charge controller. Use a flathead screwdriver to secure the wire ferrules in the terminal. Now, the Victron MPPT charge controller can be programmed. Turn on the master battery disconnect switch, open the Victron Connect app, and click on the charge controller. Here you can change the settings to the recommended parameters for the Battleborn batteries. Again, since I bought this component from Battleborn, they have already wired the unit for me. Now that we have wired the Victron Smart Solar MPPT charge controller to the Victron Lynx distributor, it is time to mount and wire the solar panels. I have 3 200 watt, 24 volt monocrystalline rigid solar panels by Rich Solar that I purchased from Battleborn. I also purchased 3 boxes of the Rich Solar Z mounting brackets from Battleborn to secure the solar panels to my flatline Vanco roof rack. Each box comes with 4 Z brackets, 4 bolts, 4 nuts, and 4 self-tapping screws. The self-tapping screws are for if you plan on drilling the Z brackets directly to the roof of your van. Therefore, I won't be needing them. I also purchased a hardware kit from Flatline Vanco to secure the solar brackets to the 80/20 crossbars that make up their roof rack. The kit includes T-nuts, lock nuts, and bolts.
Now normally you would take these brackets and attach them right to your solar panels and then attach it to a roof rack or screwing them into the roof of your van. However, I have 3 solar panels that are quite large and limited space on my roof, so I had to get a little creative with it, and I'm taking a different approach where instead I'm attaching these brackets to my crossbars first and then going to attach my solar panels so I get the most space out of the roof of my van.
To start, I added the Flatline Vanco hardware to each Rich Solar Z bracket. All brackets get 2 sets of a bolt, lock washer, and T-nut. The bolt and lock washer go on the top of the bracket, and the T-nut goes on the bottom side of the bracket. Don't make the connection too tight, so there is still room for the T-nut to slide through the 80/20 crossbar channel. To slide the bracket onto the crossbar, line up the two T-nuts to the 80/20 channel and slide the bracket into place. Now, like I said, my roof setup is very unique and different, and I have to accommodate a lot of stuff, so I'm not going to go too into detail with how I'm doing this approach. Pretty much I needed to save as much space as possible, so my solar panel, you would think if it was going between these two crossbars, that I would just use this channel and that channel, but I actually decided to use the opposite side channel to get that extra space, and then for the, see that bracket's over there, so it's kind of like back and forth. I know it's not going to make sense, but this channel, then that channel for that solar panel, that channel for that solar panel, and then that channel for that solar panel. So I kind of broke it up that way just so I could save that space and really optimize my roof. On the back of these solar panels, you see you have attaching points on both ends and then the sides as well. So to get these brackets secured in the proper location for this hole to go into the hole on the solar panel, what I did was I took one bracket and I lined it up against this and got the holes where I wanted it to be, flipped it over, tightened this down, did the same for a middle piece that has 4 brackets instead of 2, because this has 2 because it's an end piece. So did the same thing with this, and then after I had those two, I was able to just line up the ends to one another and then run the other 2 rails right next to it, flush on both ends, move the brackets to that appropriate location, and then tighten it down with an Allen wrench instead of having to line it up against the solar panel every single time. I don't know if you can see this, but this is kind of like my visual of what I was doing. Since I'm connecting to the side of my solar panels, there's 1, 2, 3, 4 holes on both sides. So I'm gonna stagger it. So that's how I was staggering it. This is the left side of the solar panel, that's the right side, just so I could have that as a visual, just to put equal help and support along the solar panel. So that's what I did. Now it's time for me to take these crossbars, flip it over on top of the solar panel, line it up with the holes, throw the bolt into it, and then tie the nut onto it. Add the bolts and nuts from the Rich Solar Z bracket mounting box to the Z bracket on the crossbar and underside of the solar panel. So once I got the crossbars lined up and the nuts and bolts loosely installed onto each of the brackets, I went around and used this scrap piece of wood to run it along the edge of the solar panel right there so that I would get the same overhang for my crossbar on both sides for all of the crossbars, so everything was nice and equal. And then I also took this and put it solar panel to solar panel, make sure that they were still nice in line and flush and everything squared. Nothing's crooked, so that'll be a lot easier to install on the roof. After I got those positioned where I wanted it to, I grabbed 2 wrenches and used one to hold down the bolt and use the other one to tighten the nut. And now all that's left to do is to connect my wires. Now on the back of each of your solar panels, you're going to have a positive and negative wire. So to connect all 3 of my solar panels together, I'm going to be connecting the wires in series, which means I'm going to be connecting a positive wire to a negative wire, a positive wire to a negative wire. Whereas the other option would be running them in parallel, which means connecting positive to positive and negative to negative. But take my word on this, you want to run your solar panels in series. I will be doing a future video where I'll explain a little bit more why that is, but I would not recommend running them in parallel. You can, it's totally up to you, but I would recommend series. Now each application is going to be different for everyone, so if you have space to connect them once they're on the van and installed, go ahead and do that route. I know personally I'm going to have to connect these before I bring these up to my van, just because I won't have enough clearance underneath to get there and connect everything. So yes, connect them in series, not parallel. So both of the wires are labeled. One is positive and one is negative. The ends of these wires have an MC4 connector. So this is the female connector and this is the male connector. So the male goes into the female when you're connecting them, and then you would just push them together, and that's how you would make that connection.
So my wires for my solar panels are going to go through a cable entry gland through the roof of my van down towards my battery bank area, my electrical setup. So I want my backmost panel to be the last one in this connection. So I'm going to start up here where the front panels are going to be, and then we can go ahead and continue making those connections, positive to negative, all the way until the last one. So I took the positive wire from this one, connected it to my negative wire of the middle solar panel, took the positive of the middle solar panel and connected it to the negative of the end solar panel. So now this end piece is going to get connected to wire extension with another MC4 connector. That way that extra wire is going to run down into my van, into my electrical. And then this negative wire on this far one that hasn't been used yet will also be connected to another wire that's going to run down into my van, into my electrical system. So that is how you wire them in series. Again, I would recommend wiring in series instead of parallel. But now it is ready to get this lifted onto the roof of my van with some help because this is very heavy and flimsy. So we're gonna get to that right now.
Thankfully, my two brothers helped me lift the panels up and refasten all the crossbars in place. Now you may be thinking, why didn't she just add one solar panel at a time to the roof? And let me remind you that the 80/20 crossbar channels cannot be accessed when they are secured between the roof rack side rails. Also, like I said, my setup is very unique, so this gave me better access to connect everything as needed. One thing I did change was I reran the solar panel wires under the crossbars instead of between the crossbar and solar panel to avoid the wires getting pinched down the road if the brackets happen to wear or fail. Also, I added zip ties to hold those wires off the roof of the van and to secure it around the 80/20 crossbar so there wouldn't be any noise when driving, and so the connections don't risk coming undone or breaking or what have you. Now that the solar panels are on the roof and wired in series, it is time to connect the solar panels to the solar isolator and the solar isolator to the MPPT charge controller. For this part of the install, I use the EXPLORIST.Life Solar Array Wiring Kit, which includes the solar isolator disconnect, 10 gauge red wire, 10 gauge black wire, a 3/8 inch red heat shrink, a 3/8 inch black heat shrink, 2 10 gauge ferrules, 4 wire glands, a roof entry gland, a solar grommet, a PV connector, and solar isolator mounting hardware. To start, determine where you plan on mounting the cable entry gland to the roof of your van. Take into consideration any obstacles on the outside and inside of the van. I noticed the cable entry gland is a little too wide for the ribs on the ProMaster roof, so it won't fit in the valley of the ribs. Therefore, I decided to place it on top of the rib. There is some slight overhang on both sides, but I'm not too worried about it as I sealed it off later in the install. I have also seen individuals who drill holes into this section in the rear of the van. Then they add entry glands and feed the wires through to the inside of the van. Personally, I didn't do this because I felt like that was a long run for my wires to go from the solar panels into the van and would just make it more complicated. But maybe that option would be better for you, so just thought I would share. So I've decided to put my cable entry gland right here underneath my solar panels. That way it's hidden. The van has a nice clean looking finish on the roof. Once I determined the location of the cable entry gland, I went back inside the van to pre-drill a hole where the cable entry gland will be placed. I pulled back my insulation, put on my safety glasses, and began pre-drilling a hole in the ceiling with a 1/16 inch drill bit. I held a vacuum in the area I was drilling to immediately catch any metal shavings created to prevent them from going freely in my van and causing rust. Well, there's another hole in my roof. Before going back to the roof of the van, I taped a box to the inside of the ceiling to catch any metal shavings that will be created when I drill a larger hole on the roof of the van. And then I also need a box on the very top of the van when I drill as well, just to capture again those little small metal shavings. So to do that, I took the box that the cable entry gland came in
and I put it in this larger box and traced it out with a marker. So now I'm going to cut it out with a box cutter and then tape this to the roof of the van.
Then, once back on the roof of the van, clean the roof where you will be mounting the cable entry gland. Place the rubber grommet over the pre-drill hole and trace the object with a dry erase marker so you have a reference when drilling with a step bit. The dry erase marker isn't permanent and will easily wipe away off of the van metal. Tape the other cardboard box that you made for the roof of the van around the traced circle. Then, make the pre-drill hole slightly larger so it can receive the step bit. I use a 5/16 inch bit to do so. Next, use a 1 inch step bit to expand the hole out to the traced line. Clean up the sharp edges with a metal file and vacuum up the metal shavings captured in the cardboard box. To protect the newly exposed metal from rust, add Rust-Oleum Stop Rust Clean Metal Primer with a foam brush, then wait 15 minutes for that to dry before applying the Rust-Oleum Stop Rust Protective Enamel with a foam brush. I left the boxes on the roof and the inside of the ceiling in place to catch any drips from this step. Once the paint has dried, the opening is ready for the rubber grommet. Using scissors, poke a hole in the center of the rubber grommet so the solar wires can be fed through the grommet and into the van. Add the rubber grommet to the hole. The metal of the van will rest in the center splice of the rubber grommet. This grommet protects the solar wires from getting cut on the sharp edges of the van's metal. Go back inside the van. Feed the black and red solar wires from the EXPLORIST.Life Solar Array Wiring Kit through the rubber grommet. Then, climb back up to the roof and add 3M double-sided VHB tape to the perimeter of the cable roof entry gland bottom. Trim off any excess and remove the back of the double-sided tape. Next, add the solar wires into the roof entry gland and push the roof entry gland into place on the roof of your van. Make sure the two grommets on the cable entry gland are facing the back of your van so no water or wind is forced in the van when you are driving. Now, tape off about 3/4 of an inch around the outside of the roof entry gland and use some Sikaflex sealant around the edges of the roof entry gland, on the flange of the roof entry gland, and out to the tape to secure the gland to the roof and seal it off from any outside elements it will encounter, like water. You will see here I am applying the Sikaflex with my fingers, and no, I do not recommend this whatsoever. Unfortunately, the tip of my Sikaflex was all dried up from the last time I used it, so instead of buying another tube, which is really expensive, I made what I had work. The sealant can be very messy, so if you get it on your hands, be aware anything you touch will turn black. An all-purpose cleaner can remove it if done so before it dries. Now be generous with this sealant to avoid any leaks in the van. It won't be visible anyways, so Sikaflex away. After applying the sealant, peel up the tape immediately after.
Now that I have the wires for my solar isolator inside the van coming up through the cable entry, I need to now put MC4 connectors on the ends of these to connect to the MC4 connectors on my solar panels. So MC4 connectors are these right here. Majority of solar panels that you get, they will come on your solar panel. So there's going to be a male and a female end. This one is the male, and then this one is the female, which is pretty self-explanatory. The male goes inside of the female. And then also, when you're installing these, you're going to have these connectors that are going to be going inside of them. So there's also a male and a female connector. The male connector is slightly smaller in diameter, and the female connector is slightly larger, again, so the male can go into the female. Now the confusing part is that the male metal clip connector goes inside the female MC4 connector, and then the female connector goes inside the male MC4 connector. So the reason that I'm using MC4 connectors, not only is it because it's already on my solar panels, but they're also waterproof, UV resistant, and they are quick and easy to connect and disconnect, and they can carry a max load of 20 amps and 600 volts. And another thing to note is if you're using MC4 connectors, they only take a 10 gauge wire.
Generally speaking, the male MC4 connector is positive and the female MC4 connector is negative. You can always double check this by placing the multimeter into the MC4 terminals. Reminder, if the multimeter display number has a negative sign in front of it, then that is indicating reverse polarity. So switch the multimeter prongs in the MC4 connectors to get a number without the negative sign, and that will tell you which connector is positive and which is negative.
So let's get to connecting them.
To start, strip back the insulation on the positive and negative solar array wires coming from the inside of the van.
So now I need to determine what MC4 connector goes on which ends. So this is a wire coming from my solar panel. It is the positive wire. So I need to connect my positive wire to positive. So since this MC4 connector on my solar panel is male, that means I will be connecting my female MC4 connector to this wire, which means I will be using the male metal connector on the inside. So I went ahead and I just placed the male connector for the positive wire in there just nice and loosely. So then once I feed this wire into there, I can just go ahead, squeeze the handles and crimp it down. Again, making sure that no stray wires are left out. Cool. So there it is, nice and crimped. So you want to make sure when you put these in that you're putting the sides with the flaps facing up right there on the top part right there. You see those little ribs? So the flaps are facing that way so that when you squeeze it, they crimp down nicely like this. And you want to make sure that's really good and snug on there by pulling on it, pulling on the wire, pulling on the connector, pulling with all of your might, and if it doesn't come off, you're good to go. So now that the male metal inside connector is on my positive wire, I'm going to take my female MC4. I'm going to unscrew this bottom piece, slide it on the wire, have this blue piece in there for a seal, and you're going to put it in here, and when you push it, you should hear it click when it's on there all the way. So let's go ahead. There. So that clicked. Hopefully you guys heard that, but you can see inside that you should be able to see that connector. Once that is on, you're going to take this and tighten it. Once you get to a certain point, about right there, you're going to feel that it gets hard to turn. That's because as you're turning right now, what it's doing is, here I'll show you on the male connector, is that it's folding these teeth inward and pinching it inward to pinch that blue piece and to pinch the wire in place. So you can get tools that will help you to turn them. You can also do it by hand or with a wrench or anything, but you want to make sure that there is no gap right here. So as you can see, the male on my solar panel is going to go into the female from the wire going down to my solar isolator, just like that. You're going to hear it click right there. There's two points right there where it clicks in. So if you want to release it, you just pinch those in and pull it apart. But otherwise, you can test it, make sure it's not going to come apart, and then you are all good to go. So now it's time to make the same connection on my negative wire to connect to the negative solar wire as well. So I'm going to add the female metal connector onto the end of this negative wire. Then I'm going to crimp it, and crimping down on those two flaps. Squeeze really tight, make sure you got that full squeeze, and then there you go. Pull, tug, make sure it's not going to come off. So now you're going to take your male MC4 connector, taking the bottom part of the cap that screws on and putting that on first, and then putting on the MC4 connector and pushing it all the way down until you hear it click, or at least feel it click. There we go. Oh, perfect. Hopefully you guys heard that one. And then you're going to screw this shut. Again, be easy to screw in the beginning, but once you hit a certain point, you really got to start cranking it. So now I just need to get my negative wire all the way on the last solar panel, all the way up in the front, feed this to it, and then our solar panels are connected and good to go.
Now the wires can be connected to the solar isolator. Before doing so, make sure the master battery disconnect switch is turned off. Grab the solar isolator and unscrew the lid to access the inside of the unit. Then remove the bottom two plugs with a flathead screwdriver. Insert the wire glands from the EXPLORIST.Life Solar Array Wiring Kit into those two openings and tighten the components together. You may recall the EXPLORIST.Life Solar Array Wiring Kit includes 4 entry glands. This is because the solar isolator can handle 2 separate solar arrays at the same time. So those 2 extra wire glands can be used on the other 2 ports at the top of the solar isolator. But if you're using just one solar array, like I am, you'll just have an extra 2 wire glands left over. Next, mount the solar isolator in place with the mounting hardware provided in the EXPLORIST.Life Solar Array Wiring Kit. Then, measure, cut, and strip the positive and negative wires coming into the van from the solar panels to feed into an entry gland of the solar isolator. I have my positive and negative wire coming into my electrical box from the solar panels, fed it up through this cable entry gland, and then put it into those terminals right there. Tighten the screws so that they're holding in place. Didn't use ferrules, wasn't necessary for this. And then on the top side, I took the solar wire cords that I cut, so the ends of that, and again I stripped the wire and inserted them into those terminals as well. So positive is in this terminal and positive is in that terminal on the bottom. So it's on the same exact line. And then again with the same thing with the negative, negative to negative. Now I'm just going to bend these wires and run them along the side of the solar isolator out this cable entry gland to my MPPT charge controller, and then I'm going to just screw the lid back on and that should be good to go. The solar isolator has 4 terminals on the bottom and the top, so use the same terminals on the bottom and top of the solar isolator when connecting a positive to a positive and negative to negative. Then strip, crimp, and heat shrink the 10 gauge ferrules onto the other end of the wire that will feed into the charge controller terminals. The positive wire goes to the PV positive terminal, and the negative wire goes to the PV negative terminal. Tighten each terminal screw with a flathead screwdriver. Now that the solar isolator is wired to the solar panels and MPPT charge controller, go ahead and turn on the master battery disconnect switch, and then the solar array isolator. Park the van in the sun, open the Victron Connect app, click on the charge controller option, and you will see that the system is indeed charging. If you don't see a charge here, it could mean something is wired wrong, or more than likely, it means that the batteries are fully charged. So the solar panels won't charge the batteries until they drain a little. Or it is super cloudy out, or you're parked in a lot of shade, or it's nighttime and no sun is out to power the solar panels. Now that we have wired for solar charging, it's time to wire for alternator charging. For this part of the install, I am using the Victron Orion 12-12-30 DC to DC charger that I purchased from Battleborn, and the EXPLORIST.Life Orion DC to DC charger wiring kit, which includes 6 gauge red wire, 6 gauge black wire, 4 6 gauge by 5/16 inch wire lugs, 4 6 gauge ferrules, 4 1/2 inch red heat shrink, 4 1/2 inch black heat shrink, a 60 amp mega fuse, and mounting hardware. First, make sure the solar disconnect switch and battery disconnect switch is turned off. Then, screw the Orion in place with the 4 screws provided in the EXPLORIST.Life Orion DC to DC charger wiring kit. Next, tape the green remote bridge from the Orion box to the Orion for safekeeping to install later. Now, measure, cut, strip, crimp, and heat shrink the positive and negative wires running from the Orion to the Lynx distributor. Each wire gets a 6 gauge by 5/16 inch wire lug and a 6 gauge ferrule. Then, wipe down the wire lugs with rubbing alcohol and a cloth for a better electrical connection. Remove the Lynx distributor hardware on the remaining studs. Add the negative wire to the negative bus bar in the Lynx distributor, and refasten the washer, lock washer, and nut over the wire lug with a 9/16 inch wrencher socket. Add the 60 amp mega fuse to the positive bus bar stud and middle stud below that. Add the positive wire lug to the lower stud that the fuse is resting on, and reapply the washer, lock washer, and nut onto both studs with a 9/16 inch wrencher socket. Now you can connect those wires from the Lynx distributor to the Orion. Negative wire ferrule to the negative output terminal, and positive wire ferrule to the positive output terminal of the Orion. Tighten these connections with a flathead screwdriver. Next, strip, crimp, and heat shrink a 6-gauge ferrule onto one end of the positive and negative wires that will run from the Orion to the van's battery. The positive wire ferrule goes into the positive input terminal, and the negative wire ferrule goes into the negative input terminal of the Orion. Tighten these connections with a flathead screwdriver.
So now you're going to connect the two wires from the Orion all the way up to the van's battery situation, which is located here on a Ram ProMaster. If you're working on another make and model like a Ford Transit or Mercedes Sprinter, this step is going to be a little bit different. But if you are in a Ram ProMaster, you can follow along here. So in order to run the wires all the way up through into this battery situation right there, I am running it through the toe kicks of my cabinetry. And then I also need to remove a lot of this plastic interior to also run it underneath all of this flooring. So to do that, I removed this section right here. There's 1, 2, 3 screws that will remove it because this is overlapping on top of this, which we need to remove. Also need to remove this section right here. So there's 1, 2 screws right here on it, and then I believe 3 of them in the back there that you'll have to undo. And then you'll also need to undo this section on your driver's seat. So 1, 2, 3 screws. And then at that point, you can go ahead and remove this whole step area. So to do that, there's 3 screws right here. You're going to take a flathead screwdriver and pop up these tabs, 1, 2, 3, and 4, which you'll be able to access once this is removed. And there's also a screw underneath each of those that you undo. And then this whole floor area is going to be exposed, and you can run your wires through there and feed it into this battery situation, which you just simply undo this section by undoing some of the tabs that go around the perimeter of this cover. So right here on the step area of my Ram ProMaster, there's these clips that were installed for wires like these right here and stuff. So I just opened those clips and threw my positive and negative wire in there as well. And then I ran it up underneath this floor on top of these wires. So I went ahead and put conduit on all the way over to the end, just to add protection to my wires. It's time to get these to connect to this whole battery situation again, which is where your feet will be in the driver's seat area. So this right here is covering your positive area of the battery. So to undo it, you just need to take these 2 tabs right there and pull it back towards you, and then you can remove the cover like that. You'll see all these fuses and stuff. So before we do anything and connect these wires to this situation, it is very, very important that you undo this negative battery situation right here. So to do that, you're going to take this thingy, I don't know what to call it. You're going to take that and fold it open. You're going to undo that nut, remove this black wire, make sure you get it out of the way so there's no chance that's actually going to fall into here when you're working on the situation. You want to do this so that you don't set off any alarms or lights or airbags or cause anything wrong with the van itself. So I'm using a 10mm wrench to remove this nut right here. Take this off and set it aside somewhere it's not going to accidentally fall back in and hit something in here, because that will be bad. So now we need to remove this entire compartment that's over the positive side of your van's battery. So to do so, you're going to release this nut right here with a 10mm wrench, which is going to release it off of this positive battery terminal. Then you also need to remove these 2 screws on the doohickey with a Phillips head tool. And then at that point, this entire section is going to lift up. Then we can feed the bolts up through those 2 holes provided, add our fuse, wire lugs, and then secure everything back down. So now you're going to feed 2 bolts up into those 2 openings so that you can create your own stud to attach the fuse and wire lug to. Now you will notice that these openings for your bolts are square head shaped. You have to get square head shaped so that when you put this back into place and you go to tighten down the bolt over your fuse and whatnot, the head of the screw won't be able to spin, so you can actually tighten the connection. If you did a circle, then that bolt is just going to keep spinning and it's not going to be able to tighten down whatsoever, if that makes sense. So here's the bolt that I'm referring to and that I will be using. I have linked them down below because I could not find these for the life of me at Lowe's, Home Depot, or any hardware stores, so they are linked below so you can get them through Amazon. But it's really critical that you get them 5/16 inch 18 thread, 1 inch long, and a 1/2 inch by 1/2 inch square head. No longer than 1 inch long, otherwise that red cover is not going to fit back over top of this. So feed those 2 bolts up into here, and then you can put this back into place and then continue from there. You want to use a nylon nut and then just put it on there. Again, the nylon nut is a 5/16 by 18 thread. So the reason I'm putting the nuts on top of these 2 bolts, not that they're going to stay there, it's just so that the bolts don't fall out while I'm trying to get this whole thing repositioned back on the battery. So once I do so, I'll be able to take these off. But I'm going to go ahead now and put this back into place. So you want this ring right here to go around this battery terminal, and then this doohickey, these red prongs, are going to line up with those 2 holes right there as well. And then you can go ahead and tighten this nut again with a 10mm wrench, and then Phillips head tool those 2 screws back into place. Now that that is back in place, it's time to cut this red wire to length. So this red wire is going to be connecting to this stud or this bolt right here. Put it back into place like this. You will notice that there's a little window right there, which is perfect so your wire can feed right into there. Sometimes I see people trying to run the wires up through here and whatnot and bend it around, but I don't want it to get pinched or anything, so I don't know, maybe since my van is a different year that's an option there. So I'm going to feed it in through that little section right there.
Now, measure, cut, strip, crimp, and heat shrink a 6 gauge by 5/16 inch wire lug. Then, wipe down the wire lugs with rubbing alcohol and a cloth for a better electrical connection.
So now I'm going to take my 1/2 inch socket and undo the nylon nut on both of those bolts that we put in so that I can add the fuse and wire lug to it accordingly. So I'm putting 2 washers on this leftmost stud because that'll help lift it to be even to that height. Then I'm adding a 60 amp mega fuse onto these 2 bolts, just like so. Now I'm going to add this wire lug onto this post right here. Now I'm going to add a flat washer onto both studs, and then a lock washer, and then a 5/16 inch lock nut that I'm going to tighten down with a 1/2 inch wrench and socket. Now you can put the cover back on so the 2 tabs are facing the middle of the van, just like so. Now it's time to cut, strip, crimp, and heat shrink on a 6 gauge by 5/16 inch wire lug onto the negative wire, which is going to connect to one of the studs over here on the negative side of the battery. And it might spark here when you add it, so just be aware of that. So I'm adding an M6 nylon nut over this stud, and I'm using an M10 socket. So now I'm going to add some of this hard-shelled split loam right here along the edges that this negative wire is rubbing up against the sharp metal edges of the van. So I'm going to open it up, feed the wire into it, and then put some electrical tape around it to hold it in place. And now I can re-add my negative van wire. You might see sparks when you touch it, but there it goes. And then retighten the lock nut that was originally on this stud, again with a 10mm socket. And then you can go ahead and take this and close it shut to tighten. What that does is it's tightening this whole component around this negative battery terminal. We can go ahead and put the cover back over the floor, and the last thing to do is take this green piece that was provided with the Orion, and you're going to install it underneath. And now I can turn on the master battery disconnect switch,
which would then allow you to connect to the Victron Orion in the Victron Connect app, but I didn't realize mine does not actually have the Bluetooth capability. But if yours does, click on the Victron Orion, update the firmware if necessary, and change the parameters to match your system. And turn the van's engine on. After about 2 to 3 minutes of the van running, you will see that the Orion is indeed charging, but if you want to see the charging rate, go to the BMV option in the Victron Connect app, and you should see somewhere around 30 amps of positive charge. So if you haven't caught on yet, this Orion allows you to charge your battery bank when you are driving. It only pulls 30 amps from your van's alternator so that it doesn't kill your van's alternator at a quicker pace over time. Now that the entire electrical system is wired and working properly, let's quickly cover a few wire management tips for a safe and clean install. Number 1, make sure all your electrical components are screwed down and secured in place. Having components loose can affect the connections over time, be a safety concern, and make it challenging to service the system. Number 2, use zip ties to coil up extra wire and to connect multiple wires together to clean up the entire system. Number 3, use rubber wire clamps to secure wires to the walls or floors so wires can't move around freely. Number 4, use split loom with electrical tape and rubber grommets to protect wires when running through the sharp metal edges of the van. I have linked all these items below in the description box for you to purchase.
With that, I hope this video gave you the confidence and knowledge you need to install your own electrical system with the EXPLORIST.Life All-In-One Wiring Kit. Tune into my next video where I will provide an explanation on how this system will function. Until then, thank you for watching, and I'll see you next time. Bye for now.